Alright guys, welcome to Properties of Logarithms. This is section 7.5 out of our text, and today what we're going to be doing is we're going to be studying properties of logarithms. And what you're going to find is that a lot of the properties that apply to exponents and exponential functions are going to apply to our logarithms. So the first thing that we're going to study, the first couple of examples, are three properties. The product rule, the quotient rule, and the power rule, all of which we have when we deal with exponents. So what the product rule tells us is that if we're multiplying two numbers in the same log, we can simply split this up using addition. Very similar to multiplying two numbers with the same base, you add their exponents. Multiplying two numbers in the same logarithm, you can separate with addition. The quotient rule tells us that if you're dividing two numbers in the same logarithm, you can separate them with a subtraction sign. And the final property is when you're taking a number raised to a power, you can move that number outside the front of the logarithm and multiply it to simplify. So those are three rules that we're going to talk about today. The most important characteristic here is you must have the same base to use these. So let's say if I give you an example here, okay, where we're starting with two logarithms we're adding, they have to have the same base in order to write the equivalent logarithm. That's very key. Now, example 1 tells us that we want to expand this logarithm. Now we're taking log base 6, 5x cubed divided by y. So here's my big indicator here, one logarithm, and I'm using division. So I'm going to start here, rewrite my problem, and I'm going to break it up, and I've used two specific colors here. So here's my numerator, subtract my denominator. Okay, once I do that, the cube is only on the x. It's not on the 5, so you've got to be very careful when you simplify. So what happens is you have 5 times x cubed. So what I do is I break up the multiplication using the product rule, log base 6 of 5 plus log base 6 of x cubed, and I leave the log base 6y. Now, this logarithm is already simplified. There's nothing else I can do. Using the power rule, I can bring that 3 out front, which I do, and I go ahead and leave that log base 6y. So here's your final answer. It's important to realize that we read these left to right, so when we're simplifying, always read left to right like a textbook. A couple things you need to be able to say. Remember, the cube was only with x. And we need to assume that all variables are positive when expanding. That's a very important note. Okay, example 2. Which is equal to log base 9 plus 3 log 2 minus log 3. So we have 4 choices. A is log 8, B is log 14, C is log 18, and D is log 24. So again, we're going to start with the expanded form and work our way backwards. I'm reading left to right, and notice I have addition here and a minus sign. So I'm actually going to multiply these together. And so you see this log base 9, or excuse me, log 9 plus, or excuse me, times 2 to the 3rd power divided by log base 3. So you have the multiplication because of the addition, and that 3 is going to go to the exponent of 2. So that's why we have log 9 times 2 cubed divided by log 3. Now you can actually simplify the 9 and 3 because they have that same base here. It's actually base 10. So 3 goes into 9, 3 times 3 goes into itself once, and we're left with log 3 times 8, which is log 24. So our answer choice for this is D. Now, change of base. This is our major property, one of our major properties with logarithms. We've talked about a graphing calculator not being able to evaluate logarithms other than base 10 on the calculator. And what this does, this formula actually allows us to evaluate any logarithm, doesn't matter what base it is, and it's called change of base. So what it tells you is if you have log base c of a, the way to write that and evaluate it is simply log a divided by log c. This also works for natural logarithms, so you can also take the natural log of a divided by the natural log of c. Note that base 10, so we can evaluate the logs on the calculator, and that's what we see here. The base is not written, so this is base 10. So we can actually plug this into our calculator and get an approximation for the logarithm, whereas without it would be much more difficult. So the natural log can be evaluated on the calculator as well, so both those can be evaluated on the calculator. So let's see what this looks like. Okay? Now, example 3. We're going to evaluate this logarithm, log base 3 of 8. So immediately I see I cannot evaluate the logarithm on the calculator because it's base 3. So using the change of base formula, I see log base 3 of 8 is equivalent to log 8 divided by log 3, which is approximately 1.89. Now, as a second part, I just showed you that it actually works for natural logarithm too, and you get this really the same expression. It's important to know that when evaluating this logarithm, you can actually use either form, natural log or logarithms, to evaluate a function. It doesn't matter, you're going to get the same result. Most people prefer to use a natural log, but it's up to you. Okay. Lastly, I just want to show you a quick example of describing and correcting errors. Something's wrong with this specific statement, and we're going to correct the error. So we have log base 2 of 5x, and whoever the person is, they wrote it's log base 2 of 5 times log base 2 of x. So we need to figure out the problem here. To me, they're trying to use the product rule. You're multiplying two numbers together, but what they do is they do rewrite with two logarithms here, but they multiply the two logs. And with the product rule, you're not supposed to do that. You actually have to add the two logarithms. So the correct response should be log base 2 of 5 plus log base 2 of x. I hope this helps, and we'll see you again for section 7.6. Thanks.